Hello, I'm back, and in this video I'd like to explain another one of the features that we've added to the analytical tool at Option Strategies. And what I'm going to do is add just one option position, a 115 call, and I'm going to only have one contract, and I'm going to use a price of 5.08, and you will see why in a moment. So if we look at our calculations here, you can see that the input calculation price is 5.08 using a 49.7 implied volatility. What we added are some position Greeks that illustrate what your gain or loss will be based on the movements of these different Greeks that are represented here. So I'm going to start by looking at position Vega. So as we know, Vega represents what the move in the value of your position is going to be with a 1% move in implied volatility. So with our position Vega is going to move $10 or approximately $10 for each 1% move in implied volatility. So if we go here, I've already input this position or the actual option inputs in our online option calculator. So we have the 115 call, and you can see the calculated price is going to be 5.08, just like we have on our analytical tool. Now, if I change implied volatility measure, or the implied volatility input rather, and then calculate the price, we come up with 5.18. So that's going to be a 10-cent move in the option value. As we know, each option represents 100 shares, and that's going to be approximately the $10 move in the value of our position, represented by the position Vega. Now, moving on to Theta. Theta is a representation of time decay. So what this is telling us is that for every day in before the option expires that passes, you're going to have a $14 loss in your position. So I can illustrate this with our online option calculator again. If I take back the implied volatility to its original input value, and I go to now there's 17 days to expiration, and all the inputs stay the same, we get a price of 4.94. So if we look at this, 5.08 minus 4.94 is 14.14 rather, and if you multiply that by 100, you get your $14 in Theta that you lost. Now, if we look at position delta, now what we know about position delta is that if a stock moves up or down 1 point, the amount that you will lose or gain is $52, approximately $52.29 based on our calculation here. However, we also know that delta is not constant, so what we have here is position gamma. So what is going to happen is as the delta moves, the delta is going to change. So approximately, it's going to be approximately $55 if the stock goes up because it's a call, so you're gaining more gamma. If the stock goes down, it's going to be approximately $49 that you're going to lose. So we can kind of, look at that. Of course, delta is not constant, so we look at, the general position here, and I can illustrate that also with our calculator. If we bring back Theta here, and the stock price goes up to 116.03, calculate the price, 5.62, and as you can see, we do have the delta plus the gamma, and considering that it's not constant, we get a $54 move in our position, 5.62, from 5.08 to 5.62, $54. Now, what happens if it goes down in price? 4.57. So, as you can see, it's going to be a $51 move. So you can, as you can see, the delta, the gamma gets subtracted from the delta, and again, it's not constant. So that's it. Thank you.